Welcome to mini lecture 1.3, Types of Studies for Chapter 1. Some important concepts that we'll talk about in this section are observational versus experimental studies and descriptive versus inferential statistics. First of all, observational versus experimental. For observational studies, we go out and take measurements, only observing what is happening. We don't act on the environment other than to measure things. Experimental studies are defined by us somehow acting on or intervening in the situation, and then our measures are there to see what the response is. This is an important difference because in order to infer causality, i.e. that A causes B, we have to have an experimental mode. We cannot say that things are causal if our study is only observational. All we can say is that things are related or correlated in that case. So here are a couple of examples. In case 1, the city of Greenfield wants to count traffic going to the state fair, so they set up an automatic traffic counter across Route 2 from both sides of the fairgrounds. In case 2, Dr. Witcher's friend Dr. Goulis studies how scent influences consumers. So he sets up a study where a store pipes in different scents, sometimes floral, sometimes spicy, and then he records the daily sales in the store. So think about which one of these is experimental and which one of these is observational. Then we want to distinguish between descriptive and inferential statistics. Descriptive statistics is our starting point. It's where we summarize our data, and we're going to learn a lot about that in Chapter 2, both visual summaries and statistical summaries. Inferential studies inferential statistics are when we generalize from our sample to the population. So usually we're using statistical summaries from our sample to make an educated guess about the population or draw a conclusion about the population. And we're going to spend a lot of time this semester talking about how to do that and how to understand our level of uncertainty associated with those educated guesses and conclusions. Here's an example to get us thinking about this. What if we have 5 midterm grades from 5 different students, 72, 65, 82, 90, and 76? Think about which of the following statements are correct and which ones you should challenge as being too generalized. In other words, you don't really trust the inference. First of all, the average midterm grade for the sample of 5 students is 77. If you calculate it, you will find that the calculated average is indeed 77. So can we say that? How about the next one? The average midterm grade for all students who took the exam is 77. That's an inference to the population of all students who took the exam. Part C. An estimate of the average midterm grade for all students who took the exam is 77. Can you say that? Can we use our 77 average as an estimate? How about D? More than half the students who take this exam will score between 70 and 85. Okay, now that's talking about a range of values that you expect to see in the population and how many you expect to see in that range. Okay. And then E, if 5 other students are included in the sample, their grades will be between 65 and 90. So if we doubled our sample size, do we expect to find the same range of values? Okay, so those are some things to think about. And then you can think about this. What if the 5 grades in the sample were all the same, 77, 77, etc.? Would you be more comfortable with some of these statements or less comfortable with some of these statements, right? What would be going on there? The other thing to think about in this chapter, starting off, is the ethics of statistics and reporting. This is a very important area. You will definitely cover some of this, the ethics of data collection and storage and reporting in SDS 100. And you should always be thinking about how to report your results in a way that is full and open and transparent. This is an actual book, How to Lie with Statistics. I have a copy of this book. It's not a how-to manual. It's a warning book about what to be concerned about. So we don't actually want to lie with statistics, and we want to develop good statistical literacy so that when we see a claim, we know how to evaluate it critically. So here's the kind of thing that you might see in an ad, for example. What if people did a survey about butter substitutes, and they want to see what doctors recommend for their patients who are concerned about cholesterol? And so what they find is that 80% of the doctors that they surveyed don't recommend anything. 5% recommend brand A, 4% recommend brand B, and all the other brands are not recommended by more than 2%. So brand A runs this ad. More doctors recommend brand A than any other brand. Um, Technically, yes, sort of, but really most doctors recommend no brand. So is this ethical? Absolutely not. This is not an appropriate way to do this. And so, watch out in the world and see what kinds of claims are being made and think about what you think about them.